All right, Item 2, Section 1.1 notes. Objective: work with real numbers and convert units. That's what we want to be able to do today. Okay. The thing about real numbers is real numbers can be broken up into two subsets. We got rational numbers, which includes a bunch of other subsets, and irrational numbers. Rational numbers are numbers that basically can be written as a fraction. So also with that, if it can be written as a fraction, then it should either end up with a terminating decimal like 0.75 or a repeating decimal like 1/3 where it goes 0.333 on forever. Okay. Um, any integer is also a rational number. An integer is a zero, a positive whole number, or a negative whole number. Okay, so that's all integers, either positive, negative, whole number. Included in whole numbers is, or in integers is whole numbers. Whole number is 0 through any positive number that's whole. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, a million, whatever. Irrational numbers are numbers that cannot be written as a fraction. They do not have a repeating decimal, and it goes on forever. So the square root of any number that is not a perfect square is an irrational number. Pi is an irrational number, probably the most famous one. And there's a few others that are irrational numbers, but mainly if it's the square root of a number that's not a perfect square and it's pi, then it's an irrational number. And you can look at that stuff. Oops. Okay. All right, so it says put these numbers in order from least to greatest, then graph them on a number line. Okay, so what we need to do on these is put them and all in the same form. And the same form, the easiest way to put them in the same form is in decimals. Okay, so we have, let me get a marker here. We got negative 0.2, that's already in a decimal. Okay, we have 7/10, which has a decimal of 0.7. Okay, and we have -1, which is already an integer, and then we have square root of 2, which is square root of 2, put that in your calculator, is approximately 1.41. And then we have -4. Okay, so if we put that from least to greatest, the smallest number is going to be -1. And then we have -0.2, or actually, sorry, check that. The smallest number is going to be -4. Okay, then -1, then -0.2, okay. Then we get to positive numbers. What's bigger? 0.7, 1.4, what 0.7 is, and then 1.41. The last thing we need to do is just change them back to their original form. -4 was -4 originally. -1 was the same. -0.2 was the same. 0.7 was actually 7/10, so we need to change that to what it was. And 1.41 was originally square root of 2. So that's how we need to rewrite it at the end so that we have them all in the correct order. And then we need to plot these, okay? So we plot -4, and we got -4 right here, okay? We plot -1. It's not very much a -1, but you get the picture. My mouse. Okay, and then we got -0.2, which is going to be very close to 0, but not quite there. Okay, and then we have 7/10, which is very close to 1, but not quite there. And then we have square root of 2, which is 1.41, so pretty much in between 1 and 2, maybe a little bit closer to 1, since this 1.5 is right in the middle. All right, so our answer would be, I know it's sloppy, I should rewrite it, but I'm not going to. Would be those numbers listed from least to greatest, and then the graph going right here. Oops, let me go back. Usually makes a pen. Everything's messing up this year. All right, so that'd be your answer. Okay. So, all right, moving on. Move to example 5. Unit analysis. You work 4 hours and earn 36. What's your hour earning rate? Well, it's a pretty easy problem to do. It's just dollars per hour. You just put $36 over 4 hours, and 36 divided by 4 is 9, so you'd have $9 per is a division sign, or you could actually write, let's write it like this, $9 per hour. Okay. You travel 2.5 miles at 50 miles per hour. How far did you go? Well, this is the distance, rate, time. You need to know that. This is one of the most important formulas is that rate equals distance divided by time. But in this case, we want distance. So what we have to do is change it. How do we get distance by itself? When we talk about this is multiplying time on both sides. Since time's on the bottom, okay, we multiply time by both sides, and we have distance equals rate times time. Okay, so if you drive this fast or this long, you're going to multiply it together to find out how far you've gone. So 50 times 2.5 is 125 miles. So the distance would be 125 miles. You drive 45 miles per hour. What is the speed in feet per second? Okay, so this is, we got to change it. We got to change what we're, we got to change. So we got 45, whatever the first unit goes on top. So 45 miles per 1 hour. Okay, and we're going to multiply that by, we're going to change miles to feet. So we're going to put, since miles is on top, we're going to put miles on bottom. And we're going to change that to feet. So how many feet are in a mile? Well, 5,280. Okay, just one of those you need to kind of just start memorizing. Think about Remember the Titans. He makes Petey run that far. Okay, and then hours. Let's do it the long way. Let's actually zoom. Zoom a little bit less. Okay, so hour, we're going to put hour, since hours are on bottom, we got to put hour on top, and we're going to put 60 minutes, and we're going to put, since minutes on bottom, we're going to put minute on top, and 1 minute equals 60 seconds. Okay, so after this, now what's going to happen is the miles cancels out, the feet cancel out, or sorry, the miles cancel out, the hours cancel out, minutes cross out, and on the left we have feet per second. Okay, so that's how you change that. So all you gotta do is multiply the top. It's 45 times 5,280, which is 237,600, and that'll be in feet. Over on the bottom we have seconds. So all we gotta do is 60 times 60, which is 3,600. Okay, so when we divide those, we get 66 feet per second will be our answer. Okay, so that's how you set up a unit analysis. One of the most real world things you can do, and something that you can use everywhere for this. Okay. Same thing. Actually, it's guided practice. Let's see. So why don't you try these ones on your own? Change 150 yards to feet, change 4 gallons to pints. I'm going to look up real quick, give you guys that information. Let's go the other way. You can always just Google these conversions if you're not sure. It's the easiest way to do it. Okay, so some of you might have known that, but there's 8 pints in a gallon. Okay, so I'll help you out if you need to do that, but you can solve those on your own. Okay, and 16 years a second, we just did one like that. Convert years, I would convert years to days, days to hours, hours to minutes, minutes to seconds. Okay, so try that one on your own. If you have questions, ask. Okay, we're going to go into 1.2, use order of operations, combine like terms. Order of operations, parentheses, exponents, multiplication, division, add, subtract, PEMDAS. You've done that a million times. You've been hearing that, I know, for a while. It's just about using them correctly. If we talk about base and power, like this one, the base will be 7. The whole thing, the power of that would be 7 squared, but the exponent is 2. So that would be 7 times 7. Or negative 5 times 4 would be parentheses negative 5 to the 4th power. Okay, so this one when we got steps over here, you can plug in, substitute negative 3 for x. So we got negative 4 times negative 3 squared minus 6 times negative 3 plus 11. So first step is substitute. Second step, the parentheses in here, there's no operations to do. So we don't have to do any operations parentheses if there's just a number in parentheses. So the next one would be exponents, which negative 3 squared, negative 3 times negative 3 is 9. So we're going to rewrite it as negative 4 times 9. Then we have negative 6 times negative 3, which is 18, plus 11. Okay. Then we have negative 4 times 9, which is negative 36, plus 18, plus 11. Negative 36 plus 18 is negative 18, plus 11, which is negative 7. Okay. So that would be your answer for this, would be negative 7. Okay. These are the same thing. Once you practice on your own, plug in 6 for x. Make sure you use PEMDAS to solve it. If you have questions, ask in class. All right. And then combining coefficients, very important. You combine a lot of polynomials, so make sure they have the same variable attached with it. Okay. So 8x plus 3x, they both have an x, they're both like terms, so you just 8 plus 3, just add the coefficients and make it 11x. Just add the coefficients. On B, if you can do this without grouping terms, you can do it, but they say to group terms, so I think it's pretty valuable to do that. So they group the like terms are the ones with the p squared. So it'd be 5p squared minus 2p squared plus p. So 5p squared minus 2p squared, then you can break that down, would be 3p squared. And then you still have your p on the outside. Now, if you could do that without grouping it, that's fine, but it's just a thing to be helpful. Okay. On C, we have to use the distributive property first. We got to do 3 times y, which is 3y, and 3 times 2, which is 6. Then we have, I treat that as a whole negative 4, make it easier. So negative 4 times y is negative 4y, and negative 4y times negative 7 is positive 28. Then if we want to group like terms, we can. We could group 3y minus 4y plus 6 plus 28, and just keep the signs together with them. So 3y minus 4y would be negative 1y, or negative y. And 6 plus 28 would be 34. So negative y plus 34, or 34 minus y, however you want to write it, both of those work. Okay, it's the same thing. You don't have to group it. If you just want to kind of draw arrows connecting them, just so you know which ones you got to combine, that's fine too. Whatever makes it easiest for you. Last one, grouping like terms. Got to group the x's together. So 2x minus 9x plus, and then negative 3y plus y. Okay. 2x minus 9x is negative 7x plus negative 3y plus y is negative 2y. So we don't want plus negative, so let's just simplify that down to negative 7x minus 2y. If you ever have a plus minus, just put a minus there, and that'd be in simplest terms. Okay. Okay, that's it. If you have any questions, bring them to class, and that is it.